All right, the formidable hot air balloon problem, right? So you've got this hot air balloon. It's perfectly spherical, right? Definitely there's a downward force on this, right? And then there's also a buoyant force up on this thing, right? And so the lifting force is, I guess, what would it be? That's on a video. That's awesome, right? So the lifting force would be a downward force. So this would be weight, right? This would be the buoyant force, right? The lifting force would be a downward force that would keep it from accelerating, I guess, right? Okay, so ultimately we say B minus the weight minus the lifting force is going to add up to 0, right? So the buoyant force is what? Rho VG minus mg minus that force is 0, right? And then this is the surrounding fluid, right? So that is, what is that? That is, the air is surrounded by an air of a density 1.34, right? So 1.34, right? The volume is 4/3 pi times, that's its radius, right? 8.74 to the third, right? Times 9.81, right? And then what's the mass of the balloon? Well, we're just going to go, I guess we're ignoring the whole thing surrounding it, right? So this is the lifting capacity of the air, is what it is, right? And so that's going to be, well, that's the density of the air in the balloon, right? So 0.9486. All right, so this is this times 4/3 pi 8.74 to the third, right? Okay, and then times 9.81, right? And then minus F is 0. Notice that these are very similar things, right? You get this a lot. This is the upward force, the buoyant force. This is the downward force, right? Basically, we're finding the lifting capacity of this. If I just find the difference in this, I should be set, right? So parentheses 1.34. What is it? 9486. All right, times 4/3 times pi times 8.74 raised to the third times 9.81. Oops. Hold on. All right, there we go. Go right arrow times 9.81. All right, are we ready for this? There we go. So when I do this, when I calculate what that force has to be, I get 10,737.7 newtons is the force, right? So really what it is, it's the lifting capacity of the hot air, right? Basically, right? All right, good enough. Hopefully you could hear all that.